Hey guys, in today's video, we're going to be learning how to convert from binary to base 10 and base 10 to binary using a visual method. So last video, we learned how to convert from binary to base 10 using expanded notation, but this time we will not be using expanded notation because personally, I actually don't usually use expanded notation to convert from binary to base 10. That expanded notation is how the ACSL website teaches it, but today I'm going to teach you a different way. And then also, last video, I forgot to mention how to convert from base 10 back to binary. So we're going to be doing that today as well. So we'll start with going from binary to base 10. Where did my mouse go? Okay. So I really like this graph from BrainPop. You can see it looks very nice. And this also helps you easily convert from binary to base 10. So say you wanted to convert the binary number 1, 1, 0 to base 10, right? You can see that there's a 1 in this column, right? So there's a 1 over this 4. So these are actually lights in the BrainPop video. You can watch the BrainPop video. It's just some BrainPop video on binary numbers. But in the video, this 4 would be lit up if there's a 1 over it. And this 2 is also lit up because there's a 1 over it. And you can clearly see that there is a 4 and there's a 2, right? So you add them together and you get 6. Okay, so I really like this graph, but on the contest, you will not have time to draw this like really pretty this pretty graph because remember in the contest you have to do 5 problems in 30 minutes. So you have limited time and you can't do this. But you can do something similar. So we'll look at that now. You can still create a sort of graph, it just won't look as nice, right? So we want to convert the same number into base 10. The way we do this is we kind of do it the same as BrainPop did. So if you have 3 digits, you just want to put the value of the digits. So basically you start with 1 on the right side, and then you double it as you go left. So it starts with 1, then it goes 2, then it goes 4. Then you put in your binary digits, and you can see that there is a 4. Oops. There's a 4, and there's a 2. And you add them together, and oops, you don't get 7, you get 6. Okay, so you can see that there's a 4, there's a 2, and there's no 1s because there's a 0 here. So 4 plus 2 is 6. Okay. Now let's try a little bit of a harder problem together. Convert 1101 in binary to base 10. So again, we're just going to list out the values. Remember, it starts from 1 and then it doubles every time. So 1, 2, 4, 8, right? Because it doubles as you go left. And now you just put in the binary digits. And you can see that there is an 8, there's a 4, there's no 2s because there's a 0, and there's a 1. You add it together, 8 plus 4 plus 1 is 13. Okay, that's pretty easy. Yeah, that wasn't too hard, right? And now I'll have you try a problem. Okay, so you can try this yourself. And if you finish or if you get stuck, then just continue the video and we'll do it together. So yeah, pause the video right now to work on it and unpause to do it together with me. Okay, so now we're just gonna work through this together to see if you got it right or to get some more practice if you got stuck. So again, you start with 1 and then you double it every time as you go left. So 1, 2, 4, 8 down here. You just plug in the binary digits. And then you can see that you have an 8, you have no 4, there's a 0, you have a 2, and you have a 1. Now you add it together. 8 plus 2 plus 1. It's 11. Okay. Cool. So that's all for converting from binary to base 10. Now we're going to move on to base 10 to binary. Again, you can see that we're going to start off by using this BrainPop's chart, okay, to explain, because I really like this and it makes it really nice to explain. So let's convert, let's say 6. Oh, no, we already used 6. We'll use, how about we use 10? Convert 10 and base 10 into binary. So the way we do this is that you basically start from the very left side and go up. Actually, the way you do this is you basically find the biggest number that goes into the base 10 number, right? So over here, what is the biggest number that you can kind of subtract from 10? So it would be 8, right? Because if you do 10 minus 16, that's a negative number. So 16 does not go into 10, but 8 does. So this 8 would be lit up. And then because we have an 8, that leaves us with only 2 left, right? Because we kind of basically put the 8 into the 10 or subtracted 8 from 10. So now we only have 2 left. So does 4 go into 2? 4 does not go into 2. But 2 does go into 2, right? So now if you subtract 2 from 2, you get 0. And does 1 go into 0? No, 1 does not go into 0. Right? So 10 in binary is 1, 0, 1, 0. Now we'll do it with a easier to set up. Well, now we'll do it with the graph. So convert 14 to binary. We'll do this one together. So here's how I do it, right? I usually start with 1 again, and then double it every time until I get a number that's greater than 14. So 16 is greater than 14, right? So you can say that 16 does not go into 14. You know that because it's greater. Now you can check if 8 is greater than 14. Well, if 8 goes into 14, and it does, right? So now we have to do 14 minus 8, which is 6. And does 4 go into 6? Yes. And then now we can do 6 minus 4, because we kind of put 4 into it. And we have 2 left. And does 2 go into 2? Yeah, it does. So now 2 minus 2 is 0. We have 0 left. And obviously 1 does not go into 0. So 14 in binary is 1, 1, 1, 0. And we can ignore all the zeros to the left because they don't really do anything. Don't mean anything. Okay. Now I'll have you try one. And yeah, so pause the video to work on this. And if you finish or get stuck, then we'll do it together. Okay. All right, now I'll explain this. So convert 27 to binary. This one was a kind of bigger number, right? So, but it's still the same strategy. You start with 1 and double it, 2, double it, 4, 8, 16, and until you get to 32. 32 does not go into 27, right? So that's a 0. And then 16, does 16 go into 27? Yes, it does. So 27 minus 16 is 11. And does 8, so you have 11 left. And does 8 go into 11? Yeah. So 11 minus 8 is 3. So you have 3 left. Does 4 go into 3? No, 4 does not go into 3. Right? So you still have 3 left. Now does 2 go into 3? 2 does go into 3. So then you do 3 minus 2, which is 1. So you have 1 left. And 1 does go into 1. So then Yeah, 1 minus 1 is 0. And by the end of this, you should have 0 left. So 27 in binary is 1, 1, 0, 1, 1. Okay, that's all for this video. I hope you found this helpful, and I'll see you in the next one.